So here's what we're doing with this. We are going to take this function and we want to calculate the points of inflection and we want to calculate the intervals for which the function is concave up or concave down. Now we talked earlier that in order for us to find the intervals of concavity, we've got to calculate the second derivative. So the first derivative is f prime of x equals the bottom times the derivative of the top, which is 0, minus the top times the derivative of the bottom, which is just 2x, all over the bottom squared. Okay, now let's simplify that before we take the derivative for the second derivative. I've got f prime of x equals negative 12x over x squared plus 3 to the second power. So there's our first derivative. So finding the second derivative is merely me calculating the derivative of the first derivative. So now I have f double prime of x equals the bottom times the derivative of the top, which is negative 12, minus the top times the derivative of the bottom. Now the bottom derivative is going to be a chain rule right here. So you're going to have 2 times x squared plus 3, reduce the power by 1, but then you have to multiply by the derivative of the inside, which is 2x. All over the bottom squared, so that's going to be x squared plus 3 to the 4th power. So now let's do the best we can to simplify. So I have f double prime of x equals, I'm just going to write this as negative 12 times, and let's go ahead and square this right here. Well, should we square it? Because maybe we can factor an x squared plus 3 out here and end up canceling it. So let's don't.
Actually, 2 of them.
Yeah, let's don't factor it yet. Let's write x squared plus 3 squared. These two negatives right here make a positive. Okay. And so I have 12x times 2 times 2x. That's 24, 48. X squared plus 48x squared times x squared plus 3, and that's all over x squared plus 3 to the 4th power. Now what you notice is I've got 2 x squareds plus 3 here because it's squared, and I've got one of them here. And so I can factor one of them out. Okay? And so what I'm going to do is I'm going to factor just one of the x squared plus 3's out. So I have f double prime of x equals, and I'm going to write this as x squared plus 3 times negative 12 times x squared plus 3 plus 48x squared all over x squared plus 3 to the 4th power. Now here's what I did, is I took one of these and I took this one out and I wrote it right here. Okay, now when I did, you can see there's still one right here, but the one that was here next to the 48x squared is no longer there because I moved it right here. Okay, now once you do that, you can cancel this with one of them from the bottom. Well, if there are 4 on the bottom, there are no longer 4, there are now how many? 3. And so now let's rewrite what we've got and let's simplify it. So I've got f double prime of x equals, and I'm going to go ahead and distribute this negative 12 here and here. So I have negative 12x squared minus 36 plus 48x squared, and that's all over x squared plus 3 cubed. So let's continue to simplify by combining like terms. So I have f double prime of x equals, now negative 12x squared and positive 48x squared is going to be 36x squared minus 36 all over x squared plus 3 cubed. Okay, so that's my second derivative. Now when we're trying to tell the points of inflection incur two ways. What will make this function undefined? And when I set the function equal to 0 and solve. Okay, so let's think of first what will make the function undefined. Now, for a function to be undefined, the bottom has to end up equaling what? 0. And so I'm going to take the bottom, x squared plus 3 all squared, and I'm going to set it equal to 0. Okay? Cubed, sorry. And so I'll cube root both sides. Okay, I'm going to cube root the left, and I'm going to cube root the right to get rid of the cubed. And what that leaves me with is x squared plus 3 equals 0. And then I'll subtract 3 on both sides. And so I have x squared equals negative 3. Is there any way I can square something and end up with a negative answer? No, so there's nothing that can make this function right here undefined. So I won't have any points of inflection on account of the denominator. Okay, so we decided that there's no way to make the denominator equal to 0, so the function's going to be defined everywhere. So let's do this now. Let's take the entire second derivative, 36x squared minus 36, all over x squared plus 3 cubed, and let's set it equal to 0 and solve. Now 0 is understood to be over 1, and when I set a function equal to 0, it's showing me where all the horizontal tangent lines are. And the location of the horizontal tangent, no, I'm on the second derivative. It's going to show me where the points of inflection are, right? If we were dealing with the first derivative, it would tell me the horizontal tangent lines, but this right here was the second derivative. Now, at this point, I'm going to cross multiply. And so I have 36x squared minus 36 equals 0. Because I multiplied these to get this. And I multiplied these right here. Well, x squared plus 3 cubed times 0 is just 0. So now all I have to do is solve that equation. So I'm going to add 36 on both sides. Okay. And so when I do that, I get 36x squared equals 36. And then what should I do? Divide 36 on both sides. Good. And so I have x squared equals 1. And so now I'm going to square root both sides. And so x equals 1 and x equals negative 1. Now, what these two are basically your critical numbers of the second derivative, which means they're the possible locations of what? Points of inflection. Good. So now what we need to do is we need to calculate the points of inflection. Two possible points of inflection. This is a possible point of inflection, and this is a possible point of inflection. Now let's review. A point of inflection is where the graph changes from being either concave down to concave up, or concave up to concave down. So what I like to do is I like to write a little number line, and I'm going to put -1 on it, and I'm going to put +1 on it. And what I like to do is I like to test to the left of -1. Oh yeah, I put two negatives up there. This is supposed to be +1. And so I want to test to the left of -1. So I want to plug in f double prime of -2. Now, when I plug in f double prime of -2, if my outcome is positive, that means that it's concave what? Up. But if my outcome's negative, then it'll be concave down. Now, in between -1 and +1 is 0, so I'm going to test f double prime of 0, and to the right of 1 is f double prime of 2. And now I don't really care so much what the actual number output is. I just want to know if it's positive or negative. So let's plug -2 in. So I've got f double prime of -2 equals 36 times -2 squared minus 36 over -2 squared plus 3 cubed. Now on top, you're going to end up with a positive number, aren't you? Okay. On bottom, you've got 4 plus 3, which is also a positive number. And so the outcome here is positive, which means that it is concave up. Very good. And now I want to plug 0 in. Okay. So I'm going to erase the negative 2 here and here. And this time I'm going to plug in a 0. 0 here and 0 here. Now, when I plug 0 in, on top, what do I get? 0 squared is 0. Yep, so it's negative because 0 minus 36 is negative 36. And on bottom, I get a positive. And so it's going to be less than 0. F double prime of 0 will be less than 0. I should have written here 0 here too. So F double prime of 0 is less than 0. Therefore, it's concave down in this interval. Okay. Lastly, I want to calculate F of what? 2. So I'm going to plug in 2 here. I'm going to calculate F double prime of 2. Okay. So 2 squared is 4 times 36 is a big number. So it's going to be positive. And on bottom, it's going to be positive as well. And so since the outcome is greater than 0, we are concave up. Now, let's look at our intervals. What we're saying is from negative infinity all the way to negative 1, we're concave what? Up. From negative 1 to positive 1, we're concave what? Down. And then at 1, it changes it going back to concave up. And so negative 1 is a point of inflection and positive 1 is a point of inflection. Now, okay, here's the graph of the actual function, right? Here's what we started with right here. We started with 6 divided by x squared plus 3. And you can see in the graph, they did a good job of drawing your point of inflection at negative 1 right here. The graph is concave up, and then at negative 1, it changes to being concave down all the way to 1, where it starts being concave what again? Up. So our calculations are verified through the graph.